In this video, we're going to talk about how to solve equations using tiles only. So I have this first slide here where we're going to talk about the different types of tiles. A tall rectangle that is not shaded in is a positive tile. A tall rectangle that is shaded in is a negative X tile. The squares, if it's a square not shaded in, it's positive integer. And if it is a shaded in square, it is a negative integer. So the purpose of these lessons is we always want to solve for our X tiles. So we're going to look at two different examples. Here's the first example where we're going to look at, we have multiple X's and multiple integers. So if you see right here, we have 3 positive X tiles, 2 positive integer tiles, and then 11 positive integer tiles over on the other side. What we want to do is our goal is to solve for this one X tile right here. I want to get this X tile all by itself. But if you see, there are 3 of them right here and then 2 integer tiles. What this is an equation where this line represents the equal sign. So we are saying that these 3 positive X tiles and the 2 positive integer tiles together equal the 11 integer tiles. So what we're going to do is we're going to get rid of the integer tiles first. All these X tiles over here are buddies. You don't split them up until later. So we're going to look at these integer tiles and we have to undo them, meaning get rid of them. So remember we talked about we can do the opposite integer tiles? So if I have 2 positive integers, I'm going to put 2 negative integers. But here's the catch. Whatever I do to one side of my equal sign, I have to do the exact same thing to the other side. So here's what's happened, and here's the reason why I did this. This positive integer cancels out this negative integer, and this positive X or integer cancels out this negative integer. I now only have these 3 X tiles left over. I do the same thing over here where I have 1, 2 that cancel each other out. So now what I want to do to show the next step, and this is really important, I want to get this X integer all by itself. So I'm actually going to flip it over on its side, and here's the reason why. When I flip it on its side, I am now going to take these remaining 1, 2, 3, 4, 5, 6, 7, 8, 9 tiles and split them evenly among these 3 X tiles. So here's what that looks like. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now notice what I did here. X's and O's are the same thing. Or I'm sorry, squares and O's are the same thing. So if you want to, so that you're not drawing X's or boxes all the time, you could do circles. They're the same thing as long as they're not shaded in. So here's the answer to our question. Notice how each X tile now has 3 integers assigned with it. So that means that one X tile all by itself is equal to 3 integer tiles. And there's your answer. X equals 3 integer tiles. And that's how you solve with multiplication or with multiple X tiles. This next example that we have right here, though, is different. Notice your X tile, you have 1 full X tile, but it's broken up into 4 sections. So this is saying right here you have a whole X, but you only have this top section right here. You then have 3 negative integers, and then you have 1, 2, 3, 4, 5 negative integers over here. Remember again, this is the equal sign, so this is saying that 1/4 of your X tile plus 3 negative tiles, integer tiles, equals 5 negative integer tiles. So again, we're going to do the same thing. We're not going to deal with this X just yet. We're going to deal with the integers right here. So again, I want to get rid of those negatives, so I put their opposites in, which are positives. I will do the exact same thing over here. Notice again we have 0 pairs. These cancel out, which is exactly what it should do. And I'm going to bring down that X tile that is divided into 4s like that. Now over here, I have 1, 2, 3 0 pairs as well. So what I'm going to do now is these two leftover tiles right here are equal to this one section right here. So here's how you show, working through this to show, okay, if this top section is worth 2 tiles, that means this next section is worth 2 positive tiles. Same here, and same here. We're not quite done yet with this. We're going to add one more step just to show you that one final X tile. So here we have that first step of undoing the integers, the second step of showing what each section is worth, and now what we're going to do is show that one full X tile is equal to 1, 2, 3, 4, 5, 6, 7, 8 positive integer tiles. And that's what 1x is equal to, 8 integer tiles.